So today here in pre-calculus, we're going to learn about the free lunch program, also known as the Binomial Theorem. It's called do you see why it's called the free lunch? Because you don't buy no meals.
Oh, God.
Anna got that one. Binomial theorem. Yes? You get it now? Right, okay. You get it now?
I get it.
Okay. Even Mrs. Voss thought that was funny. So, this is the binomial theorem. Mrs. Voss just always tells me to shut up. So, okay. X plus y to the n is equal to, this looks horrible, but it's not as horrible as it sounds, okay? NCR x to the n minus r y to the r, where right, look at those horrible letters and stuff, where NCR is equal to this n combination r, which is equal to n factorial over r factorial times n minus r, whoops, can't see that very well, times n minus r factorial. Okay? Let me just write in there. N minus r factorial. Okay? So this probably looks kind of like a foreign language to some of you. Yes? How do I move this back? What does that do? No, that'll move it down. Can I just drag? Oh, great. I want to drag this over to here. No, that didn't work. That didn't work. Oh, this slider. Okay? So this is the binomial theorem. And basically what it is, if you have an expression like x plus, if you have an expression, for instance, like x plus 2 to the 4th, x plus 2 to the 4th, instead of multiplying x plus 2 times x plus 2 times x plus 2 times x plus 2, you could use the binomial theorem to expand that, okay? Or to find any term in that expansion, which is kind of nice, because if you want to find like the third term, all you have to do is plug into the binomial theorem. How many of you seen that? Did you see that it's in Algebra 2? You probably saw this in Algebra 2, okay? So this thing here is a combination, okay? NCR can be written either like this, and sometimes they write it like this, and R, I think in the book they use this notation. But what a combination is, it's used a lot in probability. We'll talk about it more in when we get to counting principle, which we'll talk about on Monday, and then we'll be done. But with this chapter, but it's n things taken r at a time. So, for instance, a place you'd use this in real life is if you have like a committee. If you have like 10 people, so 10. Let's just do 10 combination 6, okay? Which you can rewrite as 10 6 this way. So if you have a committee of, if you have 10 people to choose from, and you want to make a committee of 6, this is the number of ways that you could make that committee. Because the order doesn't matter. We'll talk more about that on Monday. But basically, these are, if order matters, well, we'll talk about more on Monday. But let's just, this is equal to, okay, by this formula, it's equal to 10 factorial over, this number down here is r, over 6 factorial times n minus r factorial, which is 4 factorial. And that's equal to, and the way you simplify this by hand is you go 10 times 9 times 8 times 7 times 6 factorial divided by 6 factorial divided by 4 factorial. How could I write 4 factorial? How can I write 4 factorial? 4 times 3 times 2 times 1. And the reason I did that is because now I can cancel out these 6 factorials, and then I could look for other things to cancel out. See the 8? What's 4 times 2? 8. So I can cancel out the 4 times 2 since everything's being multiplied with that 8. Okay? What else goes into the top? 3 goes into 9 how many times? 3 times. Okay? So this is actually equal to 10 times 3 times 7, which is equal to 3,210. Okay, so that's how you do it by hand. Did you follow what I did? Maybe? No? Yes, sir.
And like the 10-6 would be like 10 people and 6 different.
Yeah, we'll talk more about where it's like the applications of it in probability. And that's it. But it'd be like if you had 10 people and you're choosing how many different ways I could make a committee of 6, okay? I would have 210 different ways.
And that's where position is.
The position doesn't matter,
Position
okay?
doesn't matter.
So like if someone's like sitting in that chair, that chair, that chair, that chair, the order of the people doesn't matter. It's just like, here's your committee, you know, but permutation is where the order does matter, like the batting lineup or something. We'll talk more about that on Monday. But this is just for, so let's do, you guys want to try one? Try doing this. 12, see if you can figure out 12 combination 4, okay? Which is equal to how many factorial? Harry? What's it equal to? What goes on the top?
You would get 10 or 12 factorial.
What goes on the bottom?
You would get 4 factorial
And what else?
times
8 factorial.
8 factorial.
Okay?
Okay.
So let's see if you guys can figure that out. Okay, I'm going to pause here for station identification. Okay? So now are we going? We're recording. So another way to do this is using your calculator. That's kind of the cheater method. But on a test, you will be able to use your calculator, but I'm going to ask you to show how you would do it by hand. Where's my calculator? Okay? So the way you do this, you would go 12. Watch. You go 12. Then you go to math. Then you go over to PRB, which stands for probability, because that's where this stuff comes up a lot. Okay? PRB, and you go down to NCR. Okay? So you go down here, and you hit enter, and then you just put your, what did I say? 12 combination 4. Okay? And then you put 4, and then you hit enter, and you get 495. Wow. Isn't that cool? Okay? There's another way to do it using Pascal's triangle, right? Which is kind of cool, but I have to go down to the 13th row of Pascal's triangle to get this. But 1, 3, 1, 4. Do you guys know Pascal's triangle? You add together the two terms above. It's 1 all side. We kind of did it. 1, 5. What goes to 8? No, wait. I did that right. Did I do that right?
I should say 2.
How did I get 3? Because I am addle-minded. You know what that means? It means confused. Okay? So you would get a 2. 1 plus 1 is 2, right? Then it would go 1, 3, 3. That 4, 6, 4, 1. Then it would go 1, 5, 10, 5, 10, 5, 1. And then you'd go like 1, 6, 15, 20, 15, 6, 1. Turns out that, so this is row 0, row 1, row 2, row 3, row 4, row 5, row 6. And this is column, if I were looking like at this row, this is column 1, column 2, column 3, column 4, column 5, column 6, column 7. Turns out that, like if I wanted to know, what did I say? This is row 1, 2, 3, or sorry, 0. Yeah. Row 0, 1, 2, 3, 4, 5, 6. So if I wanted 6 combination 2, I'd go to the 6th row of Pascal's triangle, and I'd go to the 2nd column, which is this one. This is 6 combination 2. Do you believe me? Watch. 6 combination 2 would be 6 factorial over 4 factorial, 2 factorial, which is 6 times 5 times 4 factorial divided by 4 factorial times 2 factorial, which is 6 times 5 divided by 2. What's 6 times 5 divided by 2? 15. See that? So like this term right here, this would be 5 combination 3. This would be 5 combination 4. This would be 5 combination 5. This would be, I mean, 0, 1, 2, 3, 4, 5, 6. Yeah, so the 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6. Yeah, so sorry, 6 combination 2. Okay? And this would be 6 combination 4, 6 combination 5, 6 combination 6. Okay? 5 combination 5, 5 combination 4, 5 combination 3, 5 combination 2, 5 combination 1, 5 combination 0. Okay? Yeah? Okay, some other things about factorials, okay, or combinations, is that n combination r is equal to n combination n minus r. For example, 12 combination 3 is equal to 12 combination 12 minus 3, which is 9. And that kind of has to do with that symmetry with Pascal's triangle, right? Or 4 combination 1 is equal to what?
Thank you.
What's 4 combination 1 equal to?
Yes, I did. And I
4 combination 3. So this combination, this is equal to this combination, this minus. Yeah? Okay? Some other properties of combinations is that n combination n minus 1 is just equal to n. For instance, 12 combination 11 is just equal to 12. Okay? So if this is 1 less than this, it's just equal to that number. Okay? Conversely, oh no, not really conversely, but n combination n is defined as 1, or you could figure that out using the formula, which is equal to n combination 0, which is also equal to 1. Okay? So now, let's use the binomial theorem. Okay? So, rather than go back, here's the binomial theorem, and what it says is this number, this number up here, okay, starts with 0, with r being 0. This is the x term. This is the y term. Okay? So the y term starts off with this exponent being 0. And this is n combination 0. Okay, so this gives you the coefficient of the term. This gives you the exponent of the x term, and this gives you the exponent of the second term. Okay? So for example, we're going to go to x plus 2 to the 4th. Okay? So, and rather than memorize this big horrible thing, okay, it's easy to just look for the pattern, which I'm going to show you. Okay? So for x plus 2 raised to the 4th power, the way you would do that, you would start off with 4 combination 0. And you would take x and raise it to the nth power, which is 4. And then you take 2 and raise it to the 0 power. Okay? These two exponents always have to add up to this number over here. Okay? This number down here agrees with this number up here. Okay? And to find this number, this minus this is always equal to that. So the next term, I'll show you, you'll see the pattern in a second. This thing goes up by 1 each time. So now you have 4 combination 1, okay? X to the, this one goes down, this one goes up. X to the 3, 2 to the first, right? Notice that this plus this always equals this, and this are always equal to each other, okay? Plus, what comes next? What? 4, 2, right? X to the, these are going down. Second, 2 to the second. Okay, next term is 4, 3. X to the, X not to the third. First, Y, or 2, sorry. 2 to the third, right? 2 to the third. Right? 2 to the third plus 4 combination 4 x to the 0 2 to the 4. Notice that if this number is 4, you're going to have 5 terms. If that number is 5, you're going to have 6 terms because you have like a 0th term and then you have 1, 2, 3, 4, right? It goes up to 4. So using the stuff I told you, this is, do you remember what 4 combination 0 is? Defined as, that's 1, okay? So what's 2 to the 0? 1, so this term just turns into x to the 4th. You guys get that? 4 combination 1 is just, what's 4 combination 1? 4, okay? 4 combination 1 is 4. If you don't believe me, you can check it out. So this becomes 4x cubed times 2. We'll worry about multiplying it out. This becomes 4 combination 2. These are also, can be found in the 4th row of Pascal's triangle. 1, 3, 3, 1, 1, 4, 6, 4, 1, even though this is the 4th row. So these exponents, this is 4. The next exponent is going to be, our coefficient, sorry, 6. This is 6, okay? X squared times what's 2 to the second? 4. Plus the next 4 combination 3 is the same as 4 combination 1, which is this point in Pascal's triangle, which is 4. X to the 1, 2 to the third, which is 8. 4 combination 4 is 1. Okay, so that's 1 times x to the 0. What's x to the 0? 1 times 2 to the 4th. And then you just simplify a little bit. X to the 4th, 2 times 4 makes 8x cubed. 6 times 4 gets 24x squared. And 4 times 8 makes 32x. And 2 to the 4th is 60. So rather than multiply x plus 2 times x plus 2 times x plus 2 times x plus 2, you can use binomial theorem. You get a free lunch. All right. So it becomes somewhat more complicated. Do you want to do a more complicated one? Yeah, you do. Okay, so what if I had 2x plus 3 raised to the 5th power? Okay? Let's just put another row of Pascal's triangle down here. 5, 10, because that way we could do it kind of faster. 5, 1. So the coefficient of the first term is going to be what? 5 combination 0. Let's just do it. 5 combination 0. But in this case, you have to take 2x and raise it to this power. So it starts out with 2x to the n, 3 to the 0, which you know is just 1, plus 5 combination 1 times 2x to the 4th, 3 to the 1st, plus that. Can you do the rest? Do I have to keep going? So this ends up being 1 times 2x to the 5th. So this is 1 times, you do have to raise it 2 to the 5th, which is 32, which is 32 x to the 5th, 3 to the 0 is 1, plus, that would be 5. 2 to the 4th is 16 x to the 4th times 3, plus the next 6 or 4 more terms. But when I simplify it, I get 32x to the 5th, plus 5 times 16 is 80 times 3, would give you 240 x to the 4th. If you kept going, just to show you what you would get the next term would be 720x cubed. The next term would be 1080x squared. 1080x squared. The next term would be 810x. 810x. And the last term would be 243, which is just 3 to the 5th power, right? Because 2x would be raised to the 0 power. We're going to have 1 in front. Okay? Yeah? We're going to do one more thing, then I'll be done. Oh, those are some neat notes. Can I do one more? You don't want me to do one more, sir? You want to send another Instagram? Okay. Okay. Oh, sorry. Snapchat. Okay. Okay. Next one. So say they said something like this. This is a little trickier. Find the coefficient. We're not done. Sorry. Coefficient of x to the 8th in x squared plus 2 raised to the 12th power. And you say, I don't know how to do that. But I do know that if I took x squared and raised it to some power, I would get x to the 8th. What do I need to raise x squared to get x to the 8th? X, 2 to the what power is x to the 8th? 4th power. So what I'm trying to find is what goes in front of here. That's the coefficient. So if x squared is raised to the 4th, what would my 2 have been raised to? What would my 2 have been raised to if the n is 8, right? 2 would have had to be raised to the 8th. Yes? Because these two numbers, this and this, always need to add to this. Okay? Over here with the combination, I have a 12 up here, and then I have combination. This number here always has to match this number down here. Okay? So I get an 8 down there. You guys understand what I just did? Okay? So this number here always has to match the exponent of the second term, and this and this always need to add up to this. Okay? Or this and this always need to add up to this. So 12 combination 8, if I did it on my calculator, what do you get? 495. Oh, we already did that one, right? So that's 495, okay? This is times x to the 8th power. 2 to the 8th, I think, is it 64? I think it's 64. No, is it bigger than that? Oh, it's way bigger than that. What is it? 256. Sorry. Okay? And then if I multiply 256 times 495, I get this evil looking number, 126,720 x to the 8th would be the coefficient of that. Okay? This would be the fourth term. I guess you would call it it's actually called since this is being raised to the fourth, what number term is this? If I were putting terms, this plus this plus this plus this plus this plus this, what number term would it be 4? It would be the 5th, because this is like the 0th term, the 1st term, the 2nd term, 3rd term, 4th term, 5th term. So 0, 1, 2, 3, 4. So it would be, this is when this is when r equals, when n minus r equals, now I'm getting myself confused. No, it would be the 9th term, because this number is 8, so it would be the 9th term in that sequence, because that one's going up from 0, 1, 2, 3, 4, 5, 6, 7, 8. So it would be the 9th term in that sequence. It would be the 9th term. Because this exponent is 8, and that exponent starts off being 0, so this would be the 9th term in that sequence. So that's kind of messed up. Okay? Okay. We're done here. I'm going to stop now. Did I pause again? Pause.